patients treated with antiviral, for example, and they recover, the groups at the top.
Hi, this is Jessica DeMassa. I'm here at the GuideWell Insights Lounge at Singularity University's Exponential Medicine 2017. Thanks for joining us. Right with me now in the Insights Lounge, I have Divya Chander. She is a faculty in medicine at Singularity, as well as a physician and researcher at Stanford. So Divya, welcome. It's great to have you.
It's my pleasure.
Thank you. I know we spoke with you last year, and so we're excited to hear what new insights you're going to bring to our conversation. So I understand that you spoke earlier today about the future of neuroscience. And so last year we had you play an analyst's role and basically tell us, so from a macro level, what's going on in neuroscience. So I'm going to start out the same way again. So give us an update. What's happening in neuroscience right now?
So one of the amazing things, and actually it's all happened since we spoke,
right after.
is actually the advent of CRISPR as a tool in neuroscience.
So talk more about that and really unpack it for us, for those that are watching that may not understand.
So CRISPR is actually, by the way, a mechanism that bacteria used in evolution to fight viruses that we're trying to invade. And that mechanism has been sort of taken over by researchers. We've now been able to package a lot of that machinery into viruses and inject them into different cells that we want to cut bad DNA out and rescue them. And there are some diseases in the nervous system that actually are inherited and because of these kinds of point mutations. And a lot of them seem to happen in the visual nervous system. So some of the first breakthroughs in CRISPR technology have been made in actually rescuing vision in diseases like retinitis pigmentosa, macular degeneration, and some movement disorders. They're starting to work with things like Huntington's disease. So that's really exciting. The one thing about CRISPR-Cas9, the current system, it's not great at helping cells that don't divide, and neurons don't divide very much. So there's a new system in the CRISPR toolbox announced 2 weeks ago.
Oh, you're kidding. Okay, so talk more about that.
Only 2 weeks ago, out of MIT, and it allows you to actually edit RNA. It comes out of Fung's lab at MIT. And this actually is going to change the face of what it means to actually edit DNA and the transcriptome RNA in neurons. So
tell me,
blows open neurological disease.
Connect all of the dots for me. What does that mean then? What does that mean if we can do that?
All of this, within the context of the way I look at neuroscience, is we are now beginning to rewire the brain from the inside out. We're rewiring the brain and cutting out things that don't work at the level of the nucleus, right? We're actually correcting diseases before they even express themselves. We're also now being able to inject stem cells. That's a new thing. Stem cell technology didn't work very well before now, but actually in visual disease, we've been able to start injecting stem cells, and the first clinical trials have been done in Japan to rescue a patient with macular degeneration. More than that, we are now using electroceuticals.
What's an electroceutical, Divya?
Unlike pharmaceuticals, which use drugs actually to help to ameliorate disease processes, but they're kind of dirty, they go everywhere, they bind to things they're not supposed to, and people get side effects. But the brain is an electrical organ, and if you can actually direct electricity right to the place where the circuit's gone bad, you can rescue all sorts of things. And electroceuticals have become so amazing that not only can we actually either invasively, so we actually implant things in the brain now that inject electricity, or we can actually stimulate from the outside using things like sound waves, ultrasound, magnetic waves, and actually get the brain to correct itself. And now we're in a closed loop world where these chips that we're implanting in the brain can actually read people's thoughts. And people who are paralyzed, for instance, and they want to be able to move, can actually send planning thoughts to a chip. The chip will intercept it using a machine learning algorithm, will actually figure out what they were trying to do and start moving actuators in the outside world.
Wow,
things like robotic arms and typing and opening email using a mouse and a keyboard, but with their thoughts.
And so it's basically reading the electrical signal in their brain? Is that what it's doing?
Absolutely.
That's incredible.
It's reading their thoughts. And there are huge companies like Facebook that are trying to capitalize this and use it to actually have devices that can drive social media without you having to physically enter things. So using your thoughts to connect to social media. Elon Musk has launched a company, Neuralink, to try to do something very similar, but his is going to be an invasive device. Facebook so far has taken a sort of a non-invasive approach, and there are even smaller startups in this space, so it's a really exciting time.
We just spoke to the co-founder of Neuralaunch, which is a neuroscience-focused accelerator program, and I'm curious to know from your perspective as somebody who is a researcher and a physician, what do we need to be careful of, if anything, about innovating in this space, and particularly taking some of these innovations, through a startup company and bringing them to market?
So I'm going to throw a little bit of ethics in here, if that's okay.
Yeah,
because sometimes
I think that merits in this conversation.
Well, you can't treat it sometimes as easily in an entrepreneurial space, and I think it's actually a conversation all of us need to be having across the board, every country, every walk of life. You can't leave it to the neuroscientists or the entrepreneurs. You have to have this joint conversation. One of our biggest ethical problems is all of this technology, this hacking of the neural code. Right now, we can actually non-invasively read brainwaves in a way we've never been able to do before. Do you know that there's a group at the University of Alabama that's actually found that if you're wearing an EEG cap and somebody's typing in a password, you can hack the passwords?
No.
Using optogenetics, we can implant false memories into mice. I'm telling you, we're actually able to read and rewire brains almost. We're getting into that place in the Matrix where Neo would just plug in and you could just inject a program in. But it's problematic too. And when you combine this with the advent of bionics and our ability to create cyborgs now with these implants, we could also create races of super soldiers. And so one thing I'd like to remind everybody is this technology has the power to transform humanity in the most beautiful way possible. But we have to remember that there are going to be certain things that we need to consider, the ramifications of this technology on the global scale.
Well, truly, and it sounds, as some of these other things that you're talking about, some of these other technologies are converging with neuroscience, with the use of stem cells and with the CRISPR, and as it's even some of those which are also kind of ethically loaded technologies. It's
you can now, just as of also a few months ago, I think it was August or September, a study was published out of Oregon where they started editing for the first time using CRISPR successfully in germline embryos in pigs, which means we can now edit basically sperm, egg.
That's crazy.
Pass it on down. Now, that's amazing. If you have a disease, an autosomal dominant disease you're going to pass to your kids, you can cut that out. But what if you start altering your genome to create things like super intelligence, super strength, to create sort of racial characteristics that you think might be more favorable? You could create an entire race of haves and have-nots.
Right.
You combine CRISPR and gene editing with implants, we might speciate. As in, we're not going to possibly be human anymore.
That's incredible.
I just want to throw that out there because
it's a valid, because I asked you to connect the dots, and so you've connected them, and we've ended up in a terrifying place.
Terrifying but interesting and possibly exciting and exhilarating. The other thing is, imagine this. These implants, by the way, do you know that we can non-invasively actually send thoughts now to other people using just the technology available, and it's just going to get more sophisticated. So when you now have implants, and these implants can be connected to computers, to other minds, imagine the hive mind situation you could create. Imagine the fact that we could maybe communicate with machines, we could communicate with a nascent AI, maybe we can endow that AI with more consciousness than it had before. And one of the, when people say, oh, you don't use all of your brain, one of the limitations of not using all your neural networks is metabolism. You can't eat enough to support your brain to actually be 100% on. Also, it would burn out because of the power issues. If you were connected up to a network that was machine-like, that could plug into a wall, you could conceivably never turn off, never burn out, and connect up to a network of things that would give you unlimited access to all the information available in the world.
How incredible. It is terrifying, and that ethical conversation, I think, is very important, and it's
yes.
As somebody who sees the beautiful potential of this, to also be able to see and speak to the terrifying side of this is good, and it speaks more to the responsibility, I guess,
we have a responsibility
as scientists and as innovators to bring those technologies to bear in a way that is safe, I guess. I don't know. That's the first word that comes to mind.
Imagine, what would you think of yourself if you had an implant that augmented you to the point that you could talk to a machine or your pet?
That's crazy.
What does that mean? Who are you?
Who am I anymore? I was just going to say, I would question who I was, what I was able to do.
Could you copy that too? Or could you, if you wanted to live forever, or you decided, I'm kind of bored of this body, so next time around when they create a new one for me, But I want my conscious experience to stay. Do you think you could copy and upload your consciousness to another avatar of yourself?
Can I? But it wouldn't be the same, would it? It would be a totally different frame of reference.
It would, and that would increase your learning experiences, but would you be able to carry a core with you? Or could you create an electrical imprint that you could store somewhere? And maybe you wouldn't have a physical avatar, but you could create a virtual avatar that would outlast you forever. And that set of electrons would evolve, but with your consciousness as the basis.
Well, I guess it brings into a question of how tied my consciousness is to this body, right?
100%. Yeah. Is consciousness like a local property of a brain or a neural net? Or is it non-local? Can you move it around? And the question is too, if machines can express consciousness, we don't know yet, but if they can express consciousness, can we move their consciousness around also? And can we switch from physical flesh to machine? And it even begins to enter that domain of the Eastern spiritual realm, right?
Okay.
Where it's like reincarnation, isn't
Yeah.
it? Right? That
you're born
takes a
again, yeah.
consciousness and moves it from one avatar to another. Right?
Divya, my mind is blown in this conversation about neuroscience, literally. Thank you so much for joining us, for
pleasure.
painting such an amazing picture on both sides of it. I mean, a very balanced view of what can happen with these technologies. It's fun to explore this with you. Thank you so much for joining us.
My pleasure.
I'm Jessica DeMassa here at the GuideWell Insights Lounge, Singularity University's Exponential Medicine 2017. Thanks for joining us.
Thank
That's
you.
incredible.